is about as easy as they come. If there's an alternating piece in it, like the -1 to the n or the -1 to the n plus 1, it's an alternating series. And if it's an alternating series, then you need to show me that the limit is 0. We usually check that anyway. And what does this mean right here? Oh, the sequence without the alternating piece is decreasing, and then that will tell us if it converges.
That's not very intensive.
No, that's why I said it's a nice one.
It's just the a to the n piece that has to converge to 0.
Yep.
And I'm guessing this converges to 0.
It just tells us if it converges. Once again, it's kind of boring.
So we'll never know what any of these series converge to. What if you have a series of series?
Nope.
CD.
So why do we need to know like if it converges or diverges if we're not figuring out what it converges to?
For what we do next.
Like what's the purpose of series?
We gotta learn all of these so that we can do what we're gonna do next week.
What's next week?
So we're gonna talk about
Integrals?
using polynomials to approximate functions that aren't polynomials.
So like writing a polynomial for like sin of x or something.
Yes.
Ooh.
Yes.
Oh, that's not.
This is gonna be like right up your alley. Okay, so I want to point out that this means that our sequence without the alternating piece needs to be decreasing. We have 3 different ways of showing that. Remember, we have our favorite, the derivative. But then we have also the ratio and the difference to where we compare to either 0 or 1, depending on what we're doing. If we can't take the derivative, it's not going to be a big one. Okay? So we're going to do a number of examples. It's probably going to take us longer to write down the example than actually do the problem. But I don't think that anyone's going to complain about that, right?
Would you like us to complain?
I watched the
Would
original
that
song
make you
of
feel
that.
more at home?
Did you have plenty of time to work on your homework during class on Friday?
Yeah, about 20 minutes. Oh, something like that. I got like half of it because I worked on Spanish. I didn't do anything.
Okay, so how many parts were there to that alternating series test? 2. So I better see 2 parts. The first, you need to look at the limit as n goes to infinity of the non-alternating part. So this is alternating, the -1 to the n plus 1. So take that out and we're left with 1 over n. Is that limit 0?
Yes.
And then number 2. We need to show that it's decreasing. How would you like to do that?
1 and 2. N equals 1 and n equals 2.
Has to be in general. Would you like to take the derivative? Would you look at the ratio, or
You can't do like we did with the direct comparison test where we just said like this function is always less than this function. So we could say like 1 over n is always
Less than 1 over n plus
greater than 1 over n plus 1.
so? Well, you could do that by looking at the ratio of the 2, right?
Yeah.
So
Okay, that makes sense. Yeah. That's
Okay.
why that's how it's a test. Yeah.
yes, but you need to like test it. Okay. So would you like to do the ratio, or would you like to do just the derivative? And I'll let you call this AST, alternating series test.
Epic.
But I need to see step 1, step 2.
Do you have to number
No, but don't make me like look all.
Day 1. Game 2.
So then our quiz on Friday, is it gonna be like over all of the tests or just?
Like, I'm going to give you a plethora of series, and you have to determine which test to use, and use that test to tell me whether it converges or diverges. Which is why we have 2 days of review. Individually, these have been fine, but when you throw them all together, you really have to think about which test is going to be best. Okay? What's nice about this, if it's alternating, there's no question. You're going to do this. Okay? Write it down. This is a nice Monday. It's awfully gray out there.
Actually, you don't start dying until you're 25.
Okay, so is this alternating?
Yes.
We know that because we have -1 to the n. So, take away the -1 to the n, and we're left with 1 over square root of n. What's that limit as n approaches infinity?
I'm guessing it's 0.
Don't guess. Know that it's 0. And then this is another one where the derivative's probably the easiest because we would have -1/2 n to the 3/2, which is always going to be less than 0. So we are for sure decreasing. Therefore, it converges by the alternating series test. This is one of those where I feel like my mind can work so much faster than what I can write. Like, you know it converges, right? Like, you can tell by looking at that the limit is 0 and you know the derivative is going to be negative, okay? And so it's like, can you get it all written down and make it look nice?
Not fast enough, apparently.
What?
Said not fast enough, apparently.
But you know what I mean? Does your brain ever work faster than your human brain?
That's anytime in English.
Anytime in English. All right, next. Throw you off your game a little bit.
I don't have a game.
You don't have a game.
Yeah, I'm just doing math. Math is a game.
What's the derivative of a factorial?
You don't have one, which is why the derivative test is not going to be functional here.
Well, then how do you do, like, the...
Just hold.
I don't
You a ratio test?
Okay, is this alternating?
Yeah, I would.
Yes. So we have our two-step process. The limit of the non-alternating piece of the series. Okay, ladies and gentlemen, I didn't say anything when they were in here, but we were not quiet when the UNO representative was in here, and we're not being very quiet as I'm trying to go through this example. You're better than that.
I do have a question.
Yes.
Would the derivative of a factorial be 0? Because, do we ever learn that?
We don't have a derivative of a factorial because we don't know how high it goes.
But like, isn't it just like a number?
Does.
And like the derivative of the number is 0?
It's not. It's a polynomial. N to the whatever power plus. I mean, because it's n times n minus 1 times.
And it's not really a function. Like it doesn't
It's not a
technically
function.
work with decimal.
Right. So what we're going to have to do is we're going to have to compare, I would say, and I heard somebody say this, the ratio of the n plus 1 term over the nth term. This is something that we talked about, I believe it was Friday, Monday? No, it would have been the week before, a week and a half ago. Okay, when we talked about sequences, we talked about this one. So our n plus 1 term would be 1 over n plus 1 factorial. Our n term would be 1 over n factorial. So let's divide by it or multiply by the reciprocal, right? That's the same thing. Okay. Well, what is this going to reduce down to? 1 over n plus 1. Okay, which we know is always going to be less than 1. And so we have shown that it's decreasing. Well, n plus 1 would be n plus 1 times n minus 1 all the way down, right? And n factorial is n times n minus 1 all the way down. So those cancel, and we're left with n plus 1.
Isn't the first term negative?
This isn't.
We, in these 2 steps, as long as it's alternating, we take out the alternating piece and we look at the non-alternating sequence for these 2 steps. Does that answer your question?
It does.
Okay.
You're really dealing with this.
So what instance does it diverge? Or does it ever diverge?
Should probably give us an example.
Well, if
You just
one of those
hold on.
don't work, the divergence.
It's
Are you
Oh,
spoiling
no.
this?
What?
Are you spoiling that it diverges? I can't believe it.
I don't know. Now, do you look at this and say, hey, it's an alternating series?
Yes, well, visually, yes.
Visually, okay, because Gabe do something like this. Okay? I mean, that's, you're
and
right.
because you're only using integers, yeah, it does alternate.
If we're only using integers, then cosine of n pi is the same as what?
Yeah, negative 1.
Wait a hot second.
That I would not have known that.
I think I would have gotten there eventually. It just would have taken a long time.
Okay? So this is an alternating series where a sub n is what?
1.
So what's the limit as n approaches infinity of a sub n? You could say alternating series test. You could say it diverges by the nth term test because our limit isn't 0. I don't care. But here would be an example of alternating series that diverges.
Sad boy.
Yes.
So once the first step is broken, you don't have to test it at all. Like you can just say that it diverges.
Correct. If the first one doesn't work, it doesn't even matter about the second. Okay. Now, was anybody bothered by this one?
Should we have been?
If we didn't have the alternating piece, the series of 1 over n, what would it do? It would diverge because it would be a p series where p is 1. But as an alternating series, it converged.
But we don't know to where, so it's still kind of hard. I kind of was like, okay, Miss Helen.
I'm still getting the hang of this.
Okay? So do you see what I mean, though? That if we had just the series of 1 over n, it would diverge. But since it's alternating with 1 over n, it converged.
Is that like a trick or something?
It's not a trick. We would just call that conditionally convergent versus absolutely convergent. So if it converges with or without the alternating piece, we call it absolutely convergent. But if it only converges because it's alternating, like the one I just pointed out, it's conditionally convergent. It's only converging because it's alternating.
Do we have to write that it's conditionally convergent?
I may ask you to in a specific situation, yes.
Like in that. in the
Well, there's times that it'll be easier to determine that than others, just like we've seen in the past week with all the tests that we've learned.
Wait, why would the absolute? Why?
Why would the what?
Oh, okay, I see.
So that absolute value is basically taking away the alternating piece,
Okay.
which is why we call it absolutely convergent. Trying to look at if it was going to start raining yet. Not yet.
So it's not start raining until like an hour and a half from now. That'll be a long time. I have stuff to do tomorrow, so I feel like
Yeah.
it's snowed in.
I haven't busted out in a while, but we're running low on stuff, so we got
You have to fill it up like every factory.
it. It's like every other.
Yeah.
Sorry to wait slow.
It's fine.
We can use just game. You do it to yourself.
I need some ice now.
There's plenty outside.
We could garage it.
No, it's a good Monday.
So
It's a solid Monday.
So nine. So 9 got made of
Dave, you just let me know when you're done.
I'm running right now. Okay, we're good. Thank you.
So 9
She's jealous.
That's my favorite.
9 means that your 9th anniversary and the area of the ground it was like literally one of the 9 days.
Okay, Gabe, you're done. You were supposed to let me know.
So I did. I'm sorry.
And so they
Okay, so come back to this one.
That's awesome.
Okay? We know that the series from 1 to infinity of 1 over n diverges because it is a p series where p equals 1. Okay? So when we talk about this converging as an alternating series, we know that it converges conditionally. Because the absolute value of it diverges. Now, I will explicitly ask you to determine conditional versus absolute convergence. So if it's just a bunch of problems and I'm saying determine convergence versus divergence, just answer that simple question like we did in the first 3 examples. But if it's alternating series and I want you to go that extra step, I will specifically ask for it. Also determine if it converges conditionally or absolute. So, here's this guy. Let's first determine if this alternating series converges or not, because then we wouldn't need to go on. So, first step, if we take away the alternating piece, we have 1 over n plus 1 squared. Is that limit 0?
Yep.
Okay. If we look at the derivative, we have negative 2 over n plus 1 cubed. So, yep, that is always less than 0. So we have a decreasing sequence is what I wanted. Okay? So we know it converges by the alternating series test, right? Now I want to know,
if it would converge via the integral test.
ooh, we don't even use the integral test.
We don't.
Well, I wouldn't, because I don't particularly care for the integral test. And I can be honest with you about that now that we have another option, right? If we wanted to do this, we have a rational with a polynomial in the denominator. We could do a comparison test. Okay? What would be an easy one to compare it to? We could compare to 1 over n squared, a convergent p series, right? Okay, I wasn't here, you don't have to remind me. We take the limit as n approaches infinity of,
It doesn't matter which.
just the ratio? I'm seeing if you remember. I know how to do it, people. Come on. Do you really think I know? Okay, Jackson says it doesn't matter, so we just throw them up there like that. The ratio of the two. And what's the limit? What does it need to be?
Any integer, as long as it's not 0.
Positive and positive. Okay? So we know that 1 over n plus 1 squared also converges by the limit comparison test. So I'm going to come back here, and we know that this guy converges absolutely. Basically 2 problems in 1, right?
Why do we have an absolute value symbol if it doesn't even involve the absolute?
Well, it does, because if I take the absolute value of this, the alternating piece goes away and I have this. Okay, now, we also need to talk about the error in our approximation, okay? So we can't always find the infinite sum, but we could find like the 6th partial sum, or the 7th partial sum, or the 8th partial sum, okay? And I want to talk about the error in that, okay? So the alternating series remainder is something that will become important. So I'm going to have you write it down, and then I'm going to talk about it. What are you snickering about? Okay, that's what I thought.
It's,
What does what mean?
sorry.
Epic game.
Is epic the word of the day?
It's just his favorite word.
Epic is a good word.
No, it's not.
You know what? I agree with you, Joe. Yeah, I absolutely agree.
They developed Fortnite.
That's Epic Games. It's a
Epic
different.
Games, same.
There was a movie called Epic.
What's that about?
It's a little
I wonder what the United States national epic is.
Okay, so this is what this is saying. The actual infinite sum, if we take the difference of that and the nth partial sum, then it's going to be, they call it remainder n, but that remainder is going to be less than or equal to the n plus 1 term. So whatever partial sum you find, it differs from the actual infinite sum by less than or equal to the next term. So if you
could approximate the actual sum.
yeah, you can have an interval of what the actual sum would be. Yes.
Do you feel confident in the interval that you have?
Are you doing confidence intervals and stats?
90
Oh, stats. Isn't stats a nice break
Yeah.
from
Yeah.
like algebra based math?
I referred to this class as real math the other day. I was like, oh, I gotta do my math homework. I mean, my real math homework. I mean, my calculus homework.
Real.
And how did Coach H take that?
No, it wasn't in class.
Oh, okay.
It was just me talking to myself.
Kaylee, what were you gonna say?
I was gonna say kind of the same thing, but it was Darby's movement, sorry.
It was stories. Write this down. And I'm gonna change it to, I feel like an even number today.
What was it?
Like, I know you have a preference. You like even numbers better than odd numbers or vice versa. Right? Have you ever thought about that?
It depends on the situation.
I'm typically more drawn towards odds, especially like prime numbers.
It's like a Russian.
I think
See?
numbers really depends.
Yep.
Be
Okay, so what I need you to do is get out your calculators. We only have 4 minutes. I need your help.
1 over n.
Please find me. Dang it, you did. Were they doing that in the video?
Yes.
Were they?
Yeah.
Oh, dang it. I was really hoping I could go a year without that.
Sorry.
What were they doing?
1 over n. It's Sorry, we have like little time.
Ever since I had Columpy in class, every year somebody does that.
Sorry, it had to be me. It's just, you know.
Okay, so the sum of the first 6 terms. So find it for me. 1 over 1 minus 1 over 2 plus 1 over 3.
1 over 6. 1 over 6.
I know.
Do you want a fraction?
No.
Okay, I got 0.632.
Oh, I
Give
just
me-
wanted to see calculator.
0.63194 repeating. The 4 repeats.
Okay.
Bar 4. I don't know how to say that.
So that's the 6th partial sum. Now, the next term, I want to know what the next term would be. So the 7th term,
That's not what I got. I do something wrong.
probably, because that's the right answer. I mean, I'm just being like factual. Like probably you did something wrong.
Are you coming over here to check now? Or are you...
Oh, see, it's factual.
Yeah, I got it.
So
Slow.
Haha.
Yeah.
Yeah.
What is
I
it?
have in my brain.
0.0 1 over 7 factorial, people. That's all I need.
1 point. Okay, 0.00198.
It's an epic game.
4126.
Okay. So our actual sum would be between. Okay, this is what we approximated the 6th partial sum to be. And we know it differs from the actual sum by no more than this next term. So if we take our 6th partial sum plus the 7th term and our 6th partial sum minus the 7th term, we have an interval of where the sum would actually converge to.
So take
So
the
why'd
average.
you write A of 7 but S of 6?
This is the sum, and this is the next term.
So take the average.
It's not the average. So our sum would be between 0.63214 and 0.63174. That's a pretty small window.
Does the window get smaller as your numbers get bigger?
So now you actually have some values to put on. Okay, do your homework, and then tomorrow we learn our last two tests. The ratio test is one of my favorites. Saving the best for last.
Oh no.
Does that make it hard?
Oh no, it's not. It's not hard. My least favorite is the integral test. So what does that tell you?